Distant learners, we're just taking our literature quiz, so sorry we're starting a few minutes later, but we're finishing up, so just hang tight for a minute and then we'll get started. That's why it didn't make any sense to me when they wanted to do 5 games with the girls with just 2 teams. It doesn't make any sense. But I think it's just, I think it's going to be like best out of 3 now. So, probably the same weekend. I think so. Yeah. Raise your hand if you still have the quiz. Go ahead and finish up. About 2 more minutes. For those of you who don't have the quiz, go ahead and take out your grammar books. For some reason, my voice is very, raspy today. Scratchy, raspy, whatever it's called. So bear with me. Don't make fun of me. If my voice cracks, sorry. I'm not going through puberty. But just an FYI. All right, go ahead and turn to page 132. We're just going to review of our lesson from yesterday, grammar. I think you did okay. Thank you. Quizzes, anybody? Quickly. All right, page 132 in grammar. Okay, which one or which noun do we use when we are talking to someone and we say their name within a sentence? Class? Direct address. Which is the word that follows a noun or explains or identifies that noun? Class? It is in a positive. Good. Thank you, Avery. Make sure everyone's there. Isaac, turn around. Open your book. Adrian, you don't need to be standing. What are you looking for? Sorry, I just stuck it in the tray. Thank you. Okay, page 132. 132. Gabby, you got to finish up, okay? Doug, do you have your quiz still? Okay. Shh, Austin. All right, page 132. So, yesterday we talked about nouns of direct address. Remember, one thing to note with nouns of direct address, make sure that you don't confuse it with the subject. So if I'm going to say, Austin, open your book. Okay, obviously your book is open. It's just an example, okay? Don't worry. Open your book is obviously the imperative command. And what is the subject of an imperative command, class? Imperative command. Imperative sentences, what is their subject? Understood you. Okay? Ameth is dying back there. You can take off the tape, if you want to. It's okay. Okay? Okay, so subjects of imperative sentences. Obviously, we know imperative sentences to be telling someone to do something, or like gives a command or makes a request, but the subject is always an understood you. You don't want to mess that up or mix that up with a noun of a direct address. So another example, Isaac, don't tilt your chair. Okay, I am directly addressing Isaac, but don't is or do, tilt would obviously be my verb, but the subject would be understood you. Okay? No. Okay? So it's just an example. What happened?
She flicks my head whenever I do this, right? And she
Yeah. That's why you shouldn't do that. Okay? So basically it would just be saying, don't tilt your chair. Okay? It's a command, but then all you're doing is adding direct address. The direct address is not the subject. Ooh, it's not the subject. It is completely unrelated grammatically to the sentence, but it is still directly addressing. Yes, Amethyst? Then take off the tape if it tickles. Okay, so that's nouns of direct address. Let's do exercise B. Okay, exercise B on page 133. Exercise B on page 133. Underline each appositive phrase, circle the appositives, draw a box around the nouns of direct address. So, just for review also with appositives, the appositive phrase is the entire phrase, obviously, hence the name phrase. Appositive is the noun of that phrase, okay? So maybe make sure you're watching for that. Number 1, men of Athens, I perceive that in all things ye are too superstitious. Okay? Do we have an appositive there? Do we have any direct addresses there? Raise your hand and let me know. Who has number 1? Andrew, do you have number 1? Good. Men of Athens is my direct address. Okay, so I would draw a box around them. Actually, this wants you to draw a box around the noun of direct address. Of Athens is basically a parenthetical phrase here, not parenthetical, prepositional phrase describing which men, but their entire name is men of Athens and who he's directly addressing. Okay? Insert commas where needed. So with nouns of direct address, what do we need after it, class? A comma. So men of Athens, comma. I perceive that in all things. Okay? Amethyst, please take off your tape because I don't want you guys passing notes in class of what you need to say. Okay? How am I supposed to know that?
Not for you.
All right, guys. So basic underlining thing. Don't pass notes. Don't pass paper, even if it's just don't touch whatever's not yours. Okay. Number 2. Ignaz Semmelweis, what a name. A Hungarian doctor, helped revolutionize medical hygiene. Okay. Are there any appositive phrases, appositives, or nouns of direct address here, class? Good. A Hungarian doctor is my entire appositive phrase. What would I circle? The appositive. What was it? Doctor is my noun appositive, okay, within that phrase. It is a non-essential. Because if you take out a Hungarian doctor, it doesn't change the fact that Ignaz Semmelweis helped revolutionize medical hygiene. So you would put commas around a Hungarian doctor as well. Number 3, plead my cause, O Lord, with them that strive with me. Okay, who is he addressing here, class? The Lord. So what would I do with Lord? Box it. And then what we do, good, commas around direct addresses. Okay, number 4, Greg, what do you know about John Wycliffe, the morning star of the Reformation? What do we have here, Adrian? What did you underline if you did anything, or box or circle? He's addressing John Wycliffe. He is. He's saying, John Wycliffe. What do you know about John Wycliffe, the morning star of the Reformation? Who is he addressing? No, who is he addressing in the beginning? What's the very first name? Greg. Greg is he is addressing. So I would box Greg. What do we do with nouns of direct address, class? Box it, but what goes after it? A comma. Okay, Greg, comma. The morning star of the Reformation would be in a positive because it's explaining, Adrian, make sure you listen to this one, okay? The morning star of the Reformation would be in a positive phrase explaining who John Wycliffe is. John Wycliffe is a person that they're talking about. Morning star of the Reformation is explaining or further saying what that man is. So I would underline that whole thing. What would I circle here? What's the noun I would circle, class? Star. He is the morning star. I would say so because it's capitalized, so that is his name. Okay? Number 5, the book Valiant for Truth has an excellent sermon by Wycliffe, Mr. Lawson. Maya, do I box anything here? No? It's not directly addressing anybody? Good. Mr. Lawson, what goes before that? What punctuation do we need? Good. A comma before Mr. Lawson. Are there any positives in this sentence? Not book. Okay, sorry, I'm talking to Maya Amethyst. No worries. So, book is my subject. So, what is explaining what the book is? Valiant for Truth. So, Valiant for Truth is my positive. Good. Okay, go ahead and turn the page to page 134. Page 134. Now, we're talking about gerund phrases. Remember, gerunds are a part of a verbal, or is a verbal. What is it used as, class? It says right there, a gerund is a verb form used as a noun. Okay, you want to mark that. So if you guys aren't familiar with gerunds, we're explaining further now the differences between verbals. So we talked about verbals. We talked about the 3 kinds of verbals. Now we're practicing identifying what kind of verbal. Okay? So now we see that a gerund is a verb form that is used as a noun. But like nouns, gerunds, they can be used as subjects, direct objects, predicate nominatives, objects of the prepositions, and appositive. So what we just learned, appositive phrases, gerunds can be explaining things. Okay, gerunds can be used as the subject, all right? Gerunds can be used as complements that are direct objects or predicate nominatives. Any noun that is used in the subject, gerunds can be used as, okay? So what does the gerund end in, class? ing. So that's how we identify a gerund. Okay, look at your example. Hunting is Tyler's favorite pastime. Okay, what's my verb there, class? My verb is, who or what is? What's my subject? Hunting, okay? Hunting is Tyler's favorite pastime. Okay, so hunting, notice how that's an ing. Hunting is a gerund. It's used as a noun here, functioning as the subject. Okay, look at the second example. Tommy really enjoys skiing. Okay, what's my verb? My verb. Enjoys. Okay, who or what enjoys? What is my subject? Tommy, what does he enjoy? Skiing. No, there's an ing there. Okay, that is, skiing is used as a gerund, okay, which is a noun. In this case, it's functioning as the direct object, okay. Juan's preoccupation is sailing. Stop doing that, please. Adrian, what's my verb there? We're still in the examples. Juan's preoccupation is sailing. Is. Awesome. Who or what is? What's my subject? Doug?
Subject is...
We're in our examples. Shh, my subject.
Want? Oh, wait, is it preoccupation?
Good. It is preoccupation. Okay. My subject is preoccupation. It is. What kind of verb is the word is? Class, action, or linking? It is linking. So therefore, what is sailing used as? Good. A PN, a predicate nominative, but notice there is an ing, so it is a gerund used as a predicate nominative. So this is just further examples of how gerunds can be used as different parts of the sentence. Okay? Number 2, a gerund phrase consists of a gerund plus any complements or modifiers. We kind of already knew that about phrases. Phrases are basically the word and then all of everything that's included with it. So, gerund phrases, look at this, okay? It's your example. They can have complements just as a verb can. Gerunds can be modified by single adverbs or prepositional phrases. The entire gerund phrase is used as a noun. Okay, so look at this. Look at our examples. Writing your assignments in a notebook is a good practice. My verb is. Who or what is? What's my subject? Writing. Writing is my gerund that is used as the subject. But writing your assignments in a notebook is basically the phrase that goes with it all. Okay? Same thing. We all enjoy eating homemade ice cream. Okay? We enjoy who or what? Eating. That's my gerund used as a direct object. However, eating homemade ice cream is that entire phrase that is used as my DO. Okay? So that is a gerund phrase, everything that it's included with it. All right? So let's do number 1 in exercise A. Okay? You're underlining each gerund. You're boxing each gerund phrase. Okay? So you're underlining the specific gerund, but then you're putting a box around the entire thing. Then you're identifying the use of the phrase, if it's used as the subject, the DO, the PN, OP, or AP. Okay? So nothing new. We are already strong in finding our subject and our verb and any complements like a DO, a PN. Okay, so let's practice it with phrases. Okay, number 1. My doctor recommends walking 3 miles every day. Okay, what's my verb here, class? Recommend. Who or what recommends? What's my subject? Doctor recommends. What does he recommend? What's my complement? Walking. Awesome. Okay, that is a gerund. So what does he enjoy? Walking. What is that used as, class? Good. It is a DO. What would I box around my entire gerund phrase? Good. I would box walking 3 miles every day. All of that is used as the direct object. Okay? Number 2. Caroline's parents tried living in the north, but they could not adapt to the cold. Okay, let's do the first part of that sentence. What's my verb there? And Caroline's parents tried living in the north. Good. Okay, tried is my verb. Who or what tried? Parents tried. What did they try? Living. Okay, that is my, what is that used as, class? A DO. Okay, what did they try? Living. What's my entire gerund phrase? Living in the north. That's what I would box. Okay, use as the direct object. Number 3, cutting an accurate pattern is the first step for a seamstress. Okay, what's my verb here? Is. Okay, we find verb first, right? So verb is my word is. Okay, who or what is? What's my subject? Cutting. Okay, that's my gerund. Obviously used as the subject, but what's my entire gerund phrase, class? Cutting an accurate pattern. That's what I would put a box around. Number 4, one of the responsibilities as a financial director, is setting limits on the budget. Okay, what's my verb here, class? Is. Who or what is? What's my subject? Not responsibilities or director. Remember, both of those are considered to be part of prepositional phrases. So yes, one is my subject. Okay, what kind of verb is the word is? It is linking. So what is it linking back to the word one? Setting. Okay, so if it's linking back, what would setting be? It is a predicate nominative. Okay, setting is what I underline. What do I box? Setting limits on the budget. That's my entire gerund phrase, used as the predicate nominative. And then number 5, let's do this one. We support missionaries by sending them money every month. Okay, what's my subject here, class? Subject. What's our verb? Support. We support who or what? Missionaries. That's my direct object. So what would by sending them money every month be? What kind of phrase is that? What kind of phrase is by sending them every month? Prepositional phrase, and we know prepositional phrases need an object, a noun object, so we know that sending is my noun object, right? Used as the OP, but what would I box? My complete gerund phrase. Sending them money every month. That's my entire gerund phrase functioning as the OP. Okay? Do 6 through 10 tonight for homework. 6 through 10. Okay? If you want more practice, you can do 6 through 20, but I'm just requiring 6 through 10. Yes, you can if you want to. 11 through 20. 6 through 10 is required. 11 through 20 can be for extra credit. Okay? I'm going to go ahead and write your homework on the board. Please note that your 6B quiz is on Tuesday. Tonight, I want you to study your synonyms. Okay? Study your synonyms. You should have turned in, not tonight, sorry. That's tomorrow night's homework. Tonight is 6B words 2 times, right? 6B words 2 times. And then read page 180 to 182 in literature, okay? 180 to 182 in literature, and then just finish that exercise that we just went over. I'll go ahead and write it on the board. Make sure you guys write it down so you get it. Some of you basketball guys need to keep in mind that it is a new semester starting next week, so if you don't turn in any homework, it's a 0, and that is your only homework, so you aren't able to travel if you have Fs, okay? So just keep in mind, and you guys have a tournament next week, so I encourage you to turn in your homework, all right? You guys are dismissed.
Hello. There we go. Okay, good to have you, discipline learners. Make sure you throw your name in the chat so I know you're here. Sorry, I had some announcements for the people here on school property. Okay, but we are to review for the test a little bit today. Hopefully you started a study sheet already at home since I wasn't here yesterday. That's another reason why we're having tests tomorrow. Okay, but we are going to review some today. I'm going to try to help you guys out a little bit. Okay, the essay, here we go. Explain the role of the Great Awakening in the birth of the United States. I'll say it again. Okay, the essay, I'll try to get you where you can write it down. You can review and try to plan your answer. Do not copy and paste Quizlet. I will give you a 0 for the test for cheating. And obviously for the essay, if you get a 0 on the test, 0 for the essay. Explain the role of the Great Awakening in the birth of the United States. Okay, the second part of the essay is this. Discuss at least 2 results of the Great Awakening. Discuss at least 2 results of the Great Awakening that prepared Americans for independence. That prepared the Americans for independence. I'll say the whole thing one more time. What? Discuss at least 2 results of the Great Awakening that prepared Americans for independence. I'll say the whole thing one more time so you can make sure you have it. Okay, explain the role of the Great Awakening in the birth of the United States. Secondly, discuss at least 2 results of the Great Awakening that prepared the Americans for independence. Okay, so you need, the essay's worth 5 total points. Okay, so I might make it worth more, but as of right now it's worth 5. Okay, so you need to have enough information. Okay, with just that, say I listed one thing from the first part, which explaining something shouldn't just be one thing. Okay, it should be like 2 or 3. Okay, and then the second part, discuss at least 2. Okay, that's 5 points. Explain is usually 2 or 3. Discuss 2, that's 5 points. You should be good right there. You can add stuff if you want. Any questions on the essay? I try to give students the essay so you can review, build your own answer, not just copying it from somewhere. Okay, build your own answer. All right, here we go. Some other things that are on there. Obviously, we talked about a lot of different people in these 2 chapters. Okay, lots of different people. We need to know them. Okay, I'm not going to go over every single thing, okay, but I'll try to review over some specific questions, give you the answers. Okay, not over every single one. We don't have time for it, all right? So I'll try to do some. Yes, ma'am. Total, there's going to be like 50. 50 questions and then the essay. Yep. For what? You get it from someone else. Should have been listening more. All right, here we go. We need to know stuff like, okay, there's lots of names, so there's 2 matching sections over names. Okay, who was known as the Sun King?
Charles, James, Louis.
Which one?
15.
Most famous Louis. The first one we mainly talked about. Louis the 14th. Louis the 14th.
That was so good. I was like, Charles.
Okay, so it's going to be difficult. Here, I'm giving you a hint. That first matching section, or one of the matching sections on there, again, I kind of rewrite the test a little bit. History's history, so I can't rewrite it completely. I mean, it's history. Okay, but I will add a few questions on my test, and I will reorganize or rearrange the stuff as well. Okay, but on one of the matching sections, you have Louis the 14th, Louis the 15th, Louis the 16th, and Louis the 18th. Okay, so know your Louis. There's a lot of them. Also know your Charles. There's 2 of them. 14, 15, 16, and 18.
I said those kings are like, we're gonna make history. Let's make
Huh? Don't need to know 17. Charles the 1st and 2nd. Okay, those are the only ones that have 1st, 2nds, or 3rds that we need to know. Charles the 1st and 2nd. They're not. Those ones aren't in the first matching section, but they are in a matching section. What? All right, there you go. All right, here we go through a few more. Again, I'm not going through everything, and I'm not man, I can't talk today with this mask. I'm not going to repeat every question. Okay, so summarize the question. These ones are short, but I'm not saying, hey, here's the whole question and answer, guys. All right, I'm not doing that. All right, let's see. Who is known as the father of New France? Father of New France. Champlain. Remember, this is over chapter 17 and 18. 18 was pretty long. Okay, it was over chapter 17 and 18. Okay, Champlain. Samuel Day Champlain. Again, those are matching. The names will be there for you. Okay, if you don't know them now by heart, they'll be there for you for hints. Okay, who is known as the great literary figure?
Samuel Johnson.
Good, Samuel Johnson. We just talked about him this chapter. Samuel Johnson. Good to see Adam, Giselle, Yuvia, Lacey, Jeremiah. Good to see you all. Who is known as the great literary figure? Samuel Johnson. No, not Samuel Jackson. Although he's pretty good at literary stuff too. He's a well-spoken man. Okay, we need to know stuff like who is known as the father of French Romanticism. Remember we talked about those ideas? Rousseau. Okay, his whole name is Jean Jacques Rousseau. Not John, Jean, Jean. Father of French Romanticism. So you could put French Romanticism equals Rousseau. Okay, that's an easy way to put it on a study sheet. Okay, who was Napoleon's second wife?
What?
Who was Napoleon's second wife? Marie what? Marie.
Is this short answer?
No.
Is this
Shh. Adrian, no. Adrian, you're really ruin it for everyone, or I'm just going to make you go outside and you can study yourself while everyone else gets to study.
Marie Louise.
There it is. Marie Louis. Marie Louis. There are a few Maries as well.
Who was Napoleon's second?
But Marie Louis. What?
I was asking what was the question. But it's Napoleon's.
Adrian, you're cool, but now you're starting to get annoying. I'm listening.
It's your last chance. Next time I hear anything out of your mouth without your hand raised, you're going outside. Okay, who said, "After me, the deluge"? 15th. Remember, Louis the 14th is the Sun King. Okay, it is Louis. Louis the 15th said, "After me, the deluge." No Elijah today? Was he here yesterday? Louis the 15th. Well, I mean, it hurts him. If he's back tomorrow, he missed the review, so it's on him. Now, okay, last one for this one. Again, there's questions I did not ask. I'm trying to ask maybe some of the harder ones. You guys should know that one. Who sailed down the Mississippi for France? You can remember he sailed. His name is LaSalle. Okay, his whole name is Robert Cavalier de LaSalle. Okay, so you can remember that. Who sailed down the Mississippi River? LaSalle. L-A space S-A-L-L-E is his last name.
What was the question?
Who sailed down the Mississippi for France? So just say sailed, Mississippi, LaSalle. That's how I remember it. Okay, there's a few more on there, a couple more on there that I didn't ask, so just be familiar. Again, know those Louis. Okay, because they're all on there. Okay, we already talked about Romanticism. Okay, true or false, the Great Awakening began with a sermon by George Whitefield to his New England church.
True. False.
Who was it? Who sparked the Great Awakening? We had it on our quiz.
Oh, it's like Robert something.
What?
Luther King.
No,
Jonathan what?
Oh.
Jonathan what? Come on, guys, we know this one.
Jonathan Edwards.
Jonathan Edwards. He sparked the Great Awakening. Okay, so he began with a sermon. There it is. Sinners in the hands of an angry God. Jonathan Edwards. Okay, George Whitefield was the most known evangelist speaker in the Great Awakening, but he did not start it. Okay, know the difference. Okay, we talked about some different beliefs in these chapters. Okay, true or false? Skepticism is the belief that experience is the only source of knowledge. It is false. What is it? Close. Remember, this is the one Amethyst believed was empires. Empiricism. 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 What did I say? So what do you need to do to talk? So what do you need to do to talk? Rick, now if you talk, you will go outside. Okay, let's see. On July 14th, 1791, a Paris mob stormed the Bastille.
True. False.
The word you're looking at is 1791. What year did the Paris mob storm the Bastille?
84,
Close.
85,
Nope.
Oh, 86.
Reverse your first numbers you just said.
87,
Oh, is it? Wait, what did I say?
68,
Closer.
89.
There it is. All right, know the date. I'm asking kind of the harder questions. That one would have been one I think you would have forgot. I'm going to say it again. Listen up. Okay, on July 14th, okay, the true number is 1789. So you want to write that down. 1789. A Paris mob stormed the Bastille. 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 Okay, let's see. Maybe another tougher question. The Battle of Leipzig is known as the Battle of Nations. True or false?
That one's easy. True.
It is true. How about this one? James Tudor succeeded Elizabeth as monarch of England. True or false? It is false. James, not Tudor. James what? What?
Oh, wait.
Nope.
The second.
What's his last name?
I thought it was William and Mary.
Wycliffe.
Not for this one. James Blank succeeded Elizabeth as monarch of England. What? There it is. James Stewart. Okay, I'm trying to ask those harder questions. Again, I told you there's a lot of names in this one. Okay, we got to know the names. There's a lot of them. James Stewart succeeded Elizabeth as monarch of England. That's why I'm trying to ask you guys some of the harder ones. Obviously some easy ones as well. Okay, know those three estates. Remember how we had the first estate of France, second estate, third estate. Know what categories goes to which one. Okay, what is the first estate?
The clergy,
Second estate,
the nobles,
third estate. There you go. Okay, know those, be familiar with those. You have a couple questions on that.
What was the question?
That's not a question. I just told you to know those. Know the first, second, and third estate. Because there's a couple questions on there. Shh, Doug. Quiet. Austin, you guys have joined Adrian and Rick. You talk again, you will go outside and review on your own. Okay, true or false? Philip Spener established a Moravian settlement on his castle. True or false? It is false. What? It's not. It is false. Okay, Philip Spener established a Moravian settlement on his estate. True or false? It is false. Okay, this one's a harder name. It's a tricky name. He's a count. There it is. Count von Zinzendorf. Zinzendorf. Again, you only need to know the last name, but the whole name is Count von Zinzendorf. Z-I-N. Yep. Zinzendorf. Yes, sir.
So, can you just put Dorf or?
You need to know the whole last name. Zinzendorf. That's how you spell it. Zinzendorf. That's his last name. What a last name. Let's see. You should know that one. Who was the philosopher of the Age of Reason? The main philosopher of the Age of Reason.
Voltaire.
Nope. John what? John Locke. John Locke. L-O-C-K-E. John Locke. Know that one. Let's see, what other one would be a tougher one? I'm not saying it again. Remember I said I'm not saying each question. So write down the name, know the name. Who began the Pietist movement? There it is, Philip Spener. Adrian Isaacs and Rick's favorite person. Austin, dude. I can't repeat everything. I'm not repeating everything. I know. What did I say if you don't get the whole question? Because I'm not repeating every question. Write down the name, Philip Spener. Look up in your notes what it is. That's all you got to do. It's not hard. I'm not answering everything for you and reading every single question for you. Okay, you have to study your own. Let's see. Who was the leader in education? Nope, a lot of us missed this one on our quiz. I didn't mark you wrong because it is tricky. Okay, who was the leader in education?
Mr. Cornell.
Yeah.
The other one. Leader in education. This one was on that quiz. Amethyst, remember you asked a question on this one? Who was the leader in education? There it is. August Frank.
Oh, yeah.
August Frank. Yep. Yep. Okay, this time it only says, this is why I'm trying to ask it because I think it's still worded poorly. I might change it in mine. I might change it in my test. Okay, but what is the leader in education? August Frank. Yes. I'll probably change it in my test. Again, my test will be very similar, obviously, but not the exact same. It'll be basically process of elimination since it's in matching. Okay, who is known as the father of American missions? You know this one. Nope. You're close. What's his last name? Judson. Adoniram Judson. It's Adoniram Judson. Gudson.
I love his name. Adoniram Judson, right?
Adoniram Judson.
Why isn't he on any of the homeworks? Why isn't he on any of the quizzes? And now all of a sudden this is a test?
He was only known for one note. We didn't really talk about him a lot.
Becca really is weak with this, so.
They are sometimes, dude. They are. It's okay. They're better than most, though. I've had other curriculums. They're better than most.
Did you do ACE and PACES?
No. No. I know what that is. That one's awful.
No, I grew up on that.
It works for some people, but it's awful. It doesn't teach you a lot.
Dude, I can't learn through Common Core stuff.
I did Bob Jones as well.
Ooh, Bob Jones?
They have pretty good science, but their math is awful.
Oh, they're mad. What's a Becca? Becca's bad enough.
No, Becca's good.
I know.
You guys have just always had a Becca, so you found the faults. And so you're like, oh, these faults. Everyone has faults. That's just what it is. Let's see. What's another harder one? Yes, tomorrow. Who was the main French cardinal we talked about? The first and main French cardinal. You're close. Mazarin. Mazarin, you're close, though. Mazarin. Mazarin. Okay, it's cardinal. His name's literally in the thing. So when you see it in the test, it's going to say French cardinal. The answer is Cardinal Mazarin. Okay, that one should be really easy. Who is the French cardinal? Cardinal Mazarin. Okay, Derek, your book should be put away because you should be writing down the stuff. This is to help you. Okay, so if you do bad tomorrow, I'm going to say, well, Derek, this is why you did bad. Yes, I heard there's a problem with a situation. If you miss something and you have to try to do it when you come back or something like that, what's going to happen is you're not taking it when you come back. Oh, well, welcome there, Elijah. I was just talking about you like 20 minutes ago. All good things. All good things. Ooh, careful. You won't take it when you get back because that's not how it works. If there's a problem, I'll deal with it. Because we're not going to talk about it. Okay, what happens when you miss a quiz if you're not here at school that day? Say it's a quiz or test tomorrow. What happens if you miss the test? You take it on Monday. So that's what's going to happen.
No, because she just
I don't know
said
yet.
that. She was like, oh, I'm going to try to give it to you guys, but really before then, I'm going to leave it here, and you guys need to, like, take it.
Yeah, we're not going to talk about it, but all you guys need to know is I'll deal with it. As athletic director, I'll deal with it. I'll tell you guys later. Your coach will tell you later. I think 2 and 3. All right, moving on.
Hey, look, that's a call. Time
I thought you said what time we were leaving. I'm sorry, Gabby. I'm sorry. I don't know yet. I said we'll talk about it at practice. Probably same times as normal. I just don't know yet. The games are supposed to be at 2 and 3, but I have to confirm those today. I was a little sick yesterday, so I didn't ask them. Girls first. All right, here we go. I'll talk about basketball later. Let's keep on moving. If it's not about history, I don't want to hear it. Quickly. All right, here we go. Who fought to abolish slavery in England? Okay, you can remember this as a hint. Okay, in the test, it's going to say he fought for his name. You fight for something. Wilberforce. Okay, he forced. Okay, Wilberforce. It's William Wilberforce. What? Yes, it was a note. We talked about a lot of people. Remember, this is chapter 7. It was kind of long. It's over France and England. It's a tough one, guys. I won't lie. It's a tougher test. Okay, who succeeded James the First? What was his son's name? Nope. What was his son's name? What do you say? Nope. Charles the First. Charles the First. Remember, we talked about how he was. Okay. Charles the First. So know that here. Hint. James the First. Okay, now you know it's not James the Second. Charles the First. First. Give you guys hints. I don't know how you remember things, but that's how I remember things. Okay, who started England's first Sunday school? Robert Raikes. Good. First English Sunday school, Robert Raikes. I feel like you guys should be able to handle most of the rest of those on that section. It's Raikes. Double R. Robert Raikes. Okay, those are the two matching sections on there. You guys have the essay, have some of the true and false. Okay, there are short answer and multiple choice. There's only 6 multiple choice. Okay, questions like this. Who succeeded William III as monarch of England? Okay, multiple choice. You have Mary II, James II, Anne, or William IV. Who succeeded William III as monarch of England? Mary II, James II, Anne, or William IV? William III as monarch of England. Pretty sure Amethyst said this earlier for a different question. Nope. It was a lady.
William and Mary and Lauren.
Anne. It was Anne. Okay, if we don't know that one, that's why I asked. I thought it was a harder one, so you know it now. Okay, who succeeded William III as monarch of England? Anne. It's just Anne. In the question, it's just Anne. All right, let's see. You should know that one. I'll ask it, whatever. What was Napoleon's greatest victory? Battle of what? Nope. Nope. What was his greatest victory? Yep. Austerlitz. 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 Litz. 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 Austerlitz. Z. Yes, sir. Yep. Okay, this one shouldn't be too hard, but it was just one thing we mentioned real quick. George Whitefield preached around how many times?
10,000 people.
How many times? Okay, options, 15,000. Austin, it is 18,000. I was going to say all the options. 18,000 is correct. 18,000 times. I want to ask these because these ones could be tougher questions. That is nuts. That's more than a lot of people's lifetime. And he just did that 18,000 times. All right, let's see. You guys should already know that. What was the main reason why Napoleon the war? No. Here's the options. Okay, there you go. Okay, failure to capture Moscow, untrained French troops, Russian winter, or Napoleon's unpopularity. Russian winter. Okay, I felt like you guys would have known it if you read it. Okay, but I just want to let you know. Let's see what else one might be hard. Okay, what about this one? Which of the following was not accomplished by August 4th decrees? Okay, noblemen could no longer collect land taxes from peasants. All citizens became office. The monarchy and everyone in France was forced to pay taxes. Which one was not? Nope. It was the third one. What is that? The monarchy no longer existed in France. That is the correct answer. That was not. Okay, so you can write this. Okay, by August the 4th decrees. Okay, which one was not? The monarchy no longer existed in France. Just bit my tongue. In France. Yep. No. That's weird. Which of the following does not describe the Committee of Public Safety? I'm asking these because I think these ones are harder. I'm just going to tell you the answer. Okay, which of the following does not describe the Committee of Public Safety? It established a stable government in France. That is the correct answer. That's what it did not. I'm not repeating it now. Get it from a friend if you missed something. All right, last section as we only have 5 more minutes. Okay, I'm going to go through it quickly, the ones I feel like you wouldn't know. This section is probably the easiest of the whole test, the short answer section. Okay, I think it's the easiest. Obviously, short answer is usually the hardest. Okay, but I think these questions are the easiest. Questions like this. What was Jonathan Edwards' most famous sermon? There you go. Okay, what was the name of the government? What was the name of the government that Oliver Cromwell established after the Commonwealth? Protectorate. Okay. Yes, you just need to know the protectorate, but yes. What? Oh, yes. Okay, what execution device became a symbol of the French Revolution? The guillotine. Guillotine. No, guillotine. Guillotine. Austin. We're almost done. Be quiet. Okay, let's see. Man, these are so easy. What was the first permanent English settlement in the New World? Okay, you guys don't even need to write these ones down. They're too easy. What religion rejected Scripture and professed that God is an impersonal being revealed only in nature? Deism. Okay, these are terms. You can write down the term, but they're so easy you should know them. Okay, what forbade the import of British goods into a European country under French control? Nope. It was a system. What forbade the importance? There it is. Continental system. That forbade the importation of British goods into any European country under French control. This one's too easy too. Name the new system of weights and measures devised during the French Revolution. Metric system. What is the name of the magnificent palace built 10 miles outside of Paris? Versailles. If I need to spell it, I can. What? Yep. Versailles. Okay, the blank attempted to apply human reason to all areas of man's life and establish a new social order. The what? The blank. It was like a time period or kind of an event. The Enlightenment. The Enlightenment. Yep, just the Enlightenment. Okay, you guys should know this one too. Who explored Australia and New Zealand for Great Britain? James Cook. All right, that is the majority of the test. Again, I did not ask every single question. I did not ask them in order. Okay, but you guys have plenty of information now from studying yesterday, studying today, okay, to be able to get an A on this test, if not a B. Okay, if you have any questions, let me know. I'll let you guys dismiss 2 minutes early. 2 minutes early. Distant learners, let me know if you have any questions. I'll send that test to you probably tonight. That will be due tomorrow. Hopefully you're doing well. We'll see you tomorrow.
All right, welcome to geometry. Let's go ahead and get started. Oh, I didn't move the webcam. Hold on a second. All right, let's try that again. There we go. Now y'all can see me. All right, we are on 2.37, page 125. Excuse me. Page 125. Let's go ahead and get right into this. Oh, real quick note about these due dates. Let me hop back in here. First of all, homework is due on Monday. That is a date change from what was originally announced. I think everyone got that one, but just to make sure. I did cancel number 5 and 2.34 because, ew. Quiz 21 will be Monday, which is over 2.37 and 2.38, open book proofs. I have not given you any pieces of information. That's what no pre-filled blanks means. What? Yeah, that's what I had. Anyway, quiz 20 is bonus due Monday. It will be on quiz 21. I think I said due Friday yesterday. I don't know why. I'm not going to grade it before quiz 21. So there you go. It's now due Monday. Yeah, you can get a 200 out of 100. Okay. Anyway, yeah, that's the same numbers I had. Okay, moving on. I talked about this yesterday. If you're a distance learner, just take a screenshot real fast. If you didn't already get this down, this is your homework proof steps. How many steps are in each proof in your homework? Let's go ahead and get moving on, though, with today. Today we're on number 8. Okay. Number 8 says that if one angle of a triangle is equal to the sum of the other two angles, A, then the triangle can be divided into two isosceles triangles, and B, the first angle is a right angle. Now, typically when they give us two things like that, it means we need to prove them in order, that A leads to B naturally. We're still going to do them in the same proof, and we're still going to do that, but in this particular instance, those are completely separate proofs. So I'll point out where the break is. Yeah, they don't really relate to each other at all. However, the advantage of doing them in the same proof is you only have to write your given once. So that's about it. That's your entire reason. And you can use the same diagram. So let's insert a diagram. And first of all, we need to prove that it's a right angle. So I'm going to go ahead and draw a right triangle, just so it's accurate, not necessarily because we're rigging it. It's just, it's going to be, so. Okay. I chose right triangle. I grabbed the rotation handle. Don't worry about it. All right. It's not isosceles yet. Okay, anyway. I want to make transparent. I want this to be 4-point line, 4-pixel line, my bad. All right, and then we will have great. I have to somehow copy. Oh, rip. Does angle 2 have to equal angle 3? All right, and this is when I actually get out my protractor and do it this way. Hold on. You be quiet. For the sake of the diagram, it's fine. Flashbacks? No, not a protractor. Okay, anyway. No, this is actually like legitimate. You would do this via construction, but when you're drawing a diagram, you don't have to worry about doing the construction. You just need to state that we can do it by construction. Okay? If you need one, you can grab one. Let's put it that way. Yeah, same idea. All right, so I'm literally holding up my protractor to my screen. Like that's legitimately how I'm doing this on the computer. So that's a 40-ish degree angle. So I need to make it where I'm trying also not to scratch my screen, because that would be really bad. All right, and then I need to create a 40-degree angle Fortunately, the properties of angles allows me to do this on the computer screen. All right, grab a line. No. What I'm doing here is I'm copying. How do I choose line? There we go. Okay. We copied this angle here to this angle here. Yeah, we're forcing the first one to be isosceles. But that's the thing we're going to draw. This actually should be a dotted line. It's actually not in the book. So there you go. There it's a dashed line. Okay, this is going to be an auxiliary line that we add later. Yeah, so here we go. All right, so let's label this thing. We're going to have triangle A. This point here will be D. Oops. Yeah, that's better. All right, and then C. What, you mean the diagrams? Because I've been doing this for a very, very, very long time. Like, my first diagrams did not look this good. Let's just be that blunt. All right, that I'm not afraid to do this and hold it up to the screen. All right, so this is what we're going to end up with. We're also going to do a lot more labeling to make our proof life easier. Okay, so we're going to make this, let go, angle 1. We're going to make this, how'd you know? Oops. Yeah, I'm just pasting the text box over and over again. Hey guys. Yeah. No, you go around in a circle. That's how we do it, so it doesn't matter. Not my problem. All right, so there is our diagram. Doing the numbers is completely optional, but it is a way to keep from having to write 3-letter combinations like over and over again and try to be like, wait, which angle is that? Okay, so that's why we're going to do that. Oh my goodness, what happened to this thing? Okay, let me zoom back out. Why is it squished? Like it completely destroyed my diagram. Great, now I got to make sure that this is the right angle. Ah. Only if you make it boring. There we go. Now it's a right angle again. I was so careful to put in a right triangle, and then it did that. All right, I'm not bitter. All right, so there's our triangle. Let me zoom back in. Okay, so hey, you guys might want to jot down this thing and stop talking over me because it's beyond rude and disrespectful and not the point of the class. Face the front, get out your textbook, let's focus. Diagram is now on the screen. This should be what you have in your book as well. And let's go ahead and insert, no, I mean as far as like in your notebook, but I forgot you guys aren't taking notes, it's habit. So table and the book had 16 steps. I can do it in 15.
Wow. It's like I could just hold in 60 steps. But I can do it.
Okay, anyway. No, really, they just have an unnecessary step in there, so I scratched it out. All right, so first of all, our given. Let's go through and talk about what given we have. First of all, what's the most obvious piece of my given?
Isosceles triangle ABC.
No, it's not given to us as isosceles. We're proving that we can get 2 isosceles triangles out of it.
Oh. So
All I know for sure is I have a triangle. Triangle ABC. And then also, I have angle CAB, which is angle 1. I am just for this case. Plus angle ABC, which is angle 4. equals angle BCA or ACB. It doesn't matter. Okay. That's our given in the question. If one angle of a triangle is equal to the sum of the other two angles, I've chosen angle C. Yes. So that is our given. Notice that CD is nowhere in my given. I am stating that. The reason why I'm mentioning angles 1 and angle 4 is because it helps us see the substitution later. So that's why I'm doing that. All right, so you have your diagram there. Let's move on to number 2. We're going to draw, or sorry, excuse me, we're going to construct. Whoops. No, we actually want to say construct on this one because we're copying the angle. CD such that angle ACD yeah. Yep. Okay. So we're constructing CD such that angle 6 equals angle 1. The only reason why I'm including the 3 letters is because that's how our given was handed to us, basically. So I'm just making sure that's there. At this point, I'm going to start just referring to numbers. But that's just so that way everything's complete. Number 3. So real quick, if angle 1 equals angle 6, what do I know then about CD and AD? Angle 1 equals angle 6. So then what do I know?
That they are equal.
Yeah, that I have equal sides. So AD equals CD.
Sides opposite equal angles in a triangle are equal.
Yep. You're fine. Number 4. All right, then I have an isosceles triangle.
Triangle ABC is
Yeah. Okay. So that's one. We're told that it makes 2 isosceles triangles, or we're told to prove that it makes 2. Huh? Yeah. Yep. So now we need to work on proving this triangle is isosceles. It's essentially the same idea, but it's got a bit more to it now. 1 and 6 was easy because we constructed it that way, so therefore it was.
3 and 6 and 5 and 6 is the same. Oops, never mind.
What? Oh yeah, you don't have parallel lines. Yeah, that's a good point. Honestly, I hadn't even caught that. All right, moving on. Nope, and it's not necessary. Actually, it is, but it's just one thing at a time. It's not. It wasn't given that it was an angle bisector. We didn't construct the bisector. So instead, here's the approach we're going to take. Notice that ACB is equal to angles 5 and angle 6. Because the whole equals the sum of all its parts. That's why. Okay? Now, we established in our given that ACB or BCA is equal to angle 1 plus angle 4. So I can plug that in if I like.
I don't like it. Don't plug it in.
Too bad. I'm doing it anyway. All right? And that's just by substitution. Now, notice that we have already established that angle 6 equals angle 1 in step 2. We constructed it that way. So I can subtract out angles 1 and 6 to just get the statement equals angle 5 by what? Good. Okay, now if then angle 4 and angle 5 are equal, then my sides are equal. CD equals BD. Yep. Like I said, it's very similar in...
Dude, that is my favorite thing. Sides opposite equal angles in a triangle are equal. Angles opposite equal sides in a triangle are equal. It's best. You can use it so versatile.
So notice that once we established that they were equal, it was fine. We just had to do a couple extra steps to get there. So no big deal. Now, that proves part A. We proved that we get two isosceles triangles. Not a problem. Okay? Now we need to go through and prove part B, which states that it's a right angle. It's going to depend on absolutely zero of the first part. Hi, we good? Okay. All right, so it's going to depend on absolutely nothing from 2 through 10. It's going to feel like we're starting a new proof because we are. Again, this could be a separate proof as well. So,
It's like a proof instead of another proof?
yeah, it's basically a second proof, but with the same given. Okay, so with this, first step, I'm just going to do some housekeeping. All the angles of a triangle has to equal a straight angle, right? Okay, so we're just going to start with that. So angle 1 plus angle 4 plus, so help me, angle ACB is equal to the big one at the top. Equals, whoops, a straight angle. Now, this next one is a duh thing, but oh wait, I actually understand. That's arguable whether or not you need to put it. Let's put it that way. Yeah, but by substitution, we have to get it in there. Yeah, I know. Now, in our given, angle 1 plus angle 4 equals angle ACB, right? Okay, so we can just substitute. I'm trying to prove angle ACB is equal to 90 degrees. Insert, special characters, degree. It doesn't like my spelling of something in math. I love Google Docs. Okay, number 13. We have to do something first. I know. Okay, I'm copying that symbol. Yeah, you have to get it into something you can divide from. All right, so now then, angle ACB is equal, 90. No, we can just do the division. Technically, honestly, we didn't need to go through 180 degrees. Why did they do that? We could have just jumped here and said equals a straight angle. 2ACB equals a straight angle. Half of... Why? No, I'm doing this without degrees. Delete. Actually, just delete the row. Whoops. Not that. I'll fix the numbering in a second. But this is actually triggering me. No, actually, we do still need the same number of steps. RIP. Because now we have to state... All right, so... Yes. Yes, it does. Yes, because it should not depend on a measurement system. And it actually really triggers me when they do that. So I'm going to have to add back in a row. Angle ACB is equal to a right angle. Actually, no, I don't. Yeah, cool. Yes, it is. I was double checking in my head. Yes, that is how we define right angle, as half a straight angle. Yeah, it's amazing what happens when you remove an necessity. All right, cool. So, thing you should write down improvement statements.
Don't worry, you guys. You just copy down from us because no one else is listening.
All right, and then I'm going to start writing down number 13. So you guys are copying down number 8. I'm working on typing in number 13. I mean,
No, you're not. You've literally been like this the whole time. You've been a horrible liar. Like for real.
is your thing added to proven statements? Uh-huh. Okay, you guys are adding number 8 to proven statements. If you get done with that, you guys can start writing 13. I don't care.
Oh, yesterday I had started writing this one. Never mind. Okay.
Wait, so you have to write this 8 and then like.
Well, 13's coming, but yeah. We haven't proven 13 yet.
You have to write the 8 thing?
You can write it as bullets if it makes you feel better or something. I would put there's 2 things in there so it's more obvious. Because then you can only use the half that it actually applies. You know what I mean? Because like if you're using it as a reason, you only need to put the part that you care about. So it's useful to have. Let's put it that way. Rip? No. That's not what I meant to do. Huh, Derrickson. What? No, it's then. Then. I'm confused. Huh? Okay. That explains a lot. Oh, this one's going to be a fun one to make. Oh. Man, how am I going to make perpendicular? Ah. This is fine. But not really.
Do we have to put in like the A and B as well?
What? Again, I would, so that way you know that there's 2 things there. Yeah. So you guys can go ahead and copy it down now. What time is it? Oh goodness. Okay, well at least this proof is shorter. Problem is drawing the diagram is going to be a pain. I know, but like more of a pain today. Let's see here. Yeah. We don't start chapter 3 until Tuesday. Hi. There's Band-Aids? You're welcome.
How would you get cut that bad? Like you really have to eat it. Like she really has to eat it.
I mean, we straight up like sandblast things to get them clean and like finished. So, and have you heard of sandpaper? Throwing that out there. Dude, it feels like someone's holding you down and sandpapering your face. I've gotten stuck in a pretty rough one before. And that's worse to drive in than fog, Because fog, you just keep your low beams on and it won't reflect back at you. In a sandstorm, no. It will reflect back at you randomly because there's particles of silica in there, which is reflective. So, like, randomly you'll get blinded. And, like, oh, goodness. Yeah, no, we should have stayed home that day. But we're moving on. No, that was in Cabazon. Yeah. It was mild as far as sandstorms go, but, like, they can get bad. And that one was one of the rougher ones from when we lived there. All right, number 13, let's go. First step is to draw a diagram. So first of all, let's read the question. The two lines joining the feet of two altitudes of a triangle to the midpoint of a third side are equal. Yeah. All right, so let's go ahead and draw ourselves a triangle. That looks vaguely like the book. Transparent, 4 pixels. All right, so now I need to first of all draw the two altitudes. So altitudes, remember, is perpendiculars. Okay, whoops, that's delete. Then I'm going to go ahead and create the altitude here, which is not the median. Okay. Well, it's just not true. Yeah, it's the midpoint, but that's not what I'm doing. Because I need the perpendicular. Yes, it is. I know it is because I used the protractor. All right, anyway. All right, then I need the midpoint from these two lines. Or sorry, these two lines to the midpoint of the third side. Now I can just use the midpoint. No. This is just the line connecting the end of the perpendicular to the midpoint of the opposite side. And then I need one more. It has to go from here. That's what we were told in the question. You'll live. All right, couple more indicators we can put in here. First of all, that these are perpendiculars, so we can go ahead and no. Okay, rip. Yeah. Okay, hold on. There's a way to do this. I'm running out of time though. Okay, so that's a perpendicular. Fine, that's fine. And then pull this up here. Yeah, I know. Can only do one thing at a time. You know what? It's close enough. Okay. And then, you know what? No, I'm not including those. You guys can hand do that. Because they're not lining up and it's like straight up triggering me. All right. And then I will also point out here very quickly that that's the midpoint. So that means we're going to have this side and this side equal. Oh. Stop that. Okay. So I'll mark that bit. Oh. No. Okay. It's true in this diagram. It's not our given. You could draw the triangle where it's not. It's just if you draw an isosceles triangle, then it's a lot easier to hit the first perpendicular. Now we get to label. So we have A. This point will be D. That way we have triangle ABC. There's E. There's M. Can we all agree that those labels are close enough? Oh, man. Am I going to have to do separate ones then? All right. Cool. There's our diagram. That's our idea. So let's go through. Okay, thank you. All right, so first of all, we have triangle ABC. Okay. We have two altitudes. Perpendiculars. They're the heights, but we say altitudes in this class for some awful reason. All right, so CD and BE. And we have M, the midpoint of BC. I usually go in alphabetical order. Okay. Number 2. Because we have altitudes, what do we have?
Right angles.
Yeah, or, well, before that, perpendicular. So CD is, oh goodness, the perpendicular symbol does not have a shortcut. CD is perpendicular to AB, and BE is also perpendicular to AC by definition of altitude. Yep. Yep, so that means angle CDB and angle BEC are right angles. Okay, which means then I have what?
90 degrees. Oh, no, right triangle. That's what Andrew said. Leg. Oh, definitely the right triangle. What was that doing?
We're trying to prove that DM equals EM in our diagram. Does that make sense? So we're trying to prove this line here equals this line here. All right, so now we have right triangles though. Now notice that because we have two right triangles, hey guys, notice that because I have two right triangles, notice that this, okay, this is now a median of this triangle. EM is a median of this triangle here. You guys see that? And then DM is now a median of this triangle because it goes from a vertex to the midpoint of the opposite side. Okay? So I can say that DM equals EM. DM is a median of triangle CDB, and that EM is a median of triangle BEC. All right, well, if I have a median that goes to a hypotenuse, how long is it? Half the hypotenuse. So that means that DM is equal to half, oh goodness, I forgot. Oh my word. Half BC, and EM equals, oh, rip. Half of BC.
Put height off. Put height. Put height. Take off optimally.
Okay, so if I have two things equal to the same thing, what does that mean about them? Helps if you spell it right. There you go. Did I still spell it wrong? Rip. There it is.
Yeah, it was substitution.
Okay, so that's number 13. And that's the end of class. All right, so real quick, make sure number 13 is in your proven statements. The text is in your book, so you guys can go through and do that. Again, you guys do have homework 2.34 to 2.37 due Monday. You have 2.34 numbers 1, 2, and 2.37 numbers 2, 3, and 19. You can do section 2.36 as bonus. Quiz 21 is Monday. I highly recommend you guys do quiz 20, which is bonus, because then you can get a 200 out of 100. So that's what we're going to do there. Beyond that, I will see y'all later.
IDLs. Starting a little late. Sorry about that. We're on lesson 87, page 2 of your notes. Let me get there. Okay, there it is. Take out a piece of paper. Okay. Piece of paper. Milestone, don't tell a teacher that, okay? Okay, here's your quiz. Yep. Is there anybody not finished here? Okay, here's your answers. 2, 5, and 6 are false. Okay. Yeah, but I can't give it to you. I'll check. Not denying what you're saying. I do need to check.
Okay.
sec. Okay. Jaden. Derek. Derek. 6. Isaac. 4. Guys, please be quiet. Andrew. Amethyst. They didn't get it. No, you didn't. Austin. What? Wait. Maya. Doug. Sophia. Lena. Adrian. Gabby. Lucy got 5. Jesse. Ricky. Elijah. Okay, thanks, Lacey. Okay. A little bit of review. What is the study of the nature, behavior, and uses of static or stationary electricity and related phenomenon? Electrostatic. Ladies, quiet please. What is the property that allows photons and neutrons to attract and repel other charged particles by the electromagnetic force? What? Nope. What are positive, negative charges? They're just the electric charge. What is the interaction between electrons and other charged particles? What did you guys say? Well, electricity. Yeah. What is an atom or other objects with an equal number of positive and negative charges? Okay. Okay. Static electricity. This is electricity, electric charge that is stationary on the surface of a charged object. So what? Guys? What causes a doorknob to get electricity? Where's the electricity come from? One at a time. Doug? Yeah. Okay, so even though, quiet please, even though there's electricity coming from the knob, it's not the knob that's creating the electricity. It's the person based upon the person walking across the floor, whether carpet or whatever, and not having any other type of ground that occurs, or grounding, I should say, occurring. person ends up touching an object, and obviously there's going to be an electrical charge coming from you to the knob. It's not the knob to you. Okay? Now, a lot of times we don't get the electrical charge because we somehow touch something, or something touches us and just it grounds us, and so the electric charge isn't there, the static electricity. Amethyst and Avery, that's one. Okay, so you got the we've all had this happen to us, especially when we're little kids. Hair flying up because of the static electricity. Or you've on a birthday or whatever put balloons on your dad's head. Okay? He probably was asleep and maybe doesn't even know he's got them on him yet. Because he kind of looks like. Okay. Haha, wasn't me. Here's Doug on some days getting out of the shower and after he's had these, wet hair and everything. Okay? When an object is electrically charged, its electrons do not necessarily go anywhere. Okay? Rather, they tend to remain stationary on the surface of the charged object. Okay? You are just creating electrical charge to them. Huh? What's what? He got shocked. He's sending it shocked him. He fell back. Okay. Okay, so static electricity is the simplest form of electricity. Static means stationary. One of the most common causes of static electricity is the friction that occurs when an object rubs against each other. And as Doug pointed out, you're walking on a floor with carpet, you're shuffling your feet, you're creating the friction. The friction, the static electricity is building in your body until you touch something and then get a shock, or touch someone else and they get a shock. Okay? Which is always fun to do. So whenever charges are built up in two objects by friction, one object is charged negatively and the other is charged positively. Okay? So there's always got to be opposite. Okay? Yes, sir. Yes. The more electrons an object gains or loses, obviously the stronger its charge. Okay? Huh? Okay. Colcum. Coulomb. I forgot to change this on the notes on my PowerPoint. It's C-O-U-L-O-M-B. Coulomb. C-O-U-L-O-M-B, not Colcum. I'll just make this switch right now. Whoever is humming, please stop, or whatever that is. Okay. There you go. SI unit of electric charge is coulomb. So, 1 coulomb of negative charge, that's a negative 1C, approximately equals the change of 6.24 times 10 to the 18th power of electrons. Okay? Keeping that formula in mind, because later on you're going to need it. A neutral object that loses 6.2 times 10 to the 18th electrons possesses a positive coulomb of okay, so it's going to be a plus 1 coulomb. Okay? Does that make sense? If one thing is a neutral object, a neutral is what? An atom or other objects with an equal number of positive and negative charges. So if a neutral object that loses the 6.24 or the negative 1 coulomb, it now possesses a positive 1. Okay? So let's put some electric laws to this. First of all, you got the law of electric charges. Okay? This is the law stating that the opposite charges attract each other, but like charges repel each other. Person walks up to the doorknob, shocks the doorknob. What has the positive, what has the negative? Huh? Okay. So, the doorknob or the finger doesn't have, both of them don't have the negative. There's got to be a positive and there's got to be a negative. Okay? Huh? Nope. The phenomena of electric charges is responsible for that static cling. Okay? Static cling when you pull your clothes out of the dryer. Okay? Same type of perspective, only just a different realm of it. So that's the law of electric charges. Then you have the law of electric force. This is the law that's stating that the strength of the attraction or repulsion between the two charged objects is directly related to the strength of the charge and inversely related to the square of the distance between them. Okay? Andrew? Static plane. Okay, so the strength of the attraction or the repulsion. Gabby? And Lena? And Doug? Okay, so you've got the attraction, you got the repulsion. Okay? Two charges directly related to the strength of the charge. Obviously, the further away charges are, or the objects are, the less the charge is going to be. Okay? So therefore, inversely related to the square of the distance. Okay? That's the law of the electric force. Here's your formula to do that. It's in your book or in your notes. Force equals constant, okay, times the strength of the first charge times the strength of the second charge divided by the distance of the two objects squared. Okay? Or, paraphrasing that, F equals constant, which is K. The strength, Q of the first, Q1, strength of the second, Q2, divided by the distance between the two objects, the radius squared. Okay? So the value of the constant K depends upon the material separating the charges. That's what we're basing this all upon. So in a vacuum, K equals 8.99 times 10 to the ninth. Neutrons times meter squared per coulomb squared. Yep. Okay. But all you gotta do is put numbers in where the letters are and simple algebra. Okay? Yep, simple algebra. Work it out just simply and you come up with a simple algebra answer. Okay. Simple. Okay? No. Simple. Not simple, simple. Simple. Okay? You guys make math too hard. Okay? So, okay, changing the charge of one object proportionally changes the attraction or the repulsion between it and another object. Okay? Now, these are just common sense principles. Okay? But it sounds more complicated when we put it into words. Okay? But all we're basically saying with this is that the further the things are away from each other, the less the charge. Closer they get, the more electrified they get. Okay? So if the electric force between two objects is 10 newtons, and the charge of one object is reduced from 10 coulombs to 1 coulomb, 1/10 of the original charge, the force of attraction or repulsion is reduced to 1 newton, or 1/10 of the original force. Okay? Everybody see what they did there? Okay? Saw what they did? Simple math. This isn't even algebra. This is 5th grade math. Okay? Okay? So increasing the distance between two charged objects decreases the force of attraction or repulsion by the square of the distance. Okay? I had something I could say right now, but I won't. I'll withstrain. I'll withstrain. Nope. Nope. No. Huh? I don't have any cookies. No. I'll be kind even though Valentine's Day is coming up. If the distance between two objects is tripled, okay, the electric force decreases to 1/9 of its original magnitude. Okay? Lacey, I'm sparing you the embarrassment right now. Okay? Okay? Sweet. What was I, Gabby, what was I gonna say? You got the idea. Okay? Now see, I don't even have to say these things anymore. Okay? You all know just exactly what I'm thinking, what I'm talking about. But all we can say, Isaac, is let the force be with you.
Okay. Check this out. It's on the screen right now. It's not even worth watching anymore.
Gabby, and Doug.
Wow.
No, sit down. Okay. Now, shh, quiet. Get the ratios of these guys. Hey, enough. Get the ratio. Doug, that's two. Get the ratios of what's being talked about here. Going back, yes you can. If the distance between two objects is tripled, okay, then the force between them is 1/9 of what it would be if they were closer, okay? So all you are doing is squaring it up, okay? Simple math. Simple math, okay? Next time you watch Star Wars, watch how much algebra is being used in the show, okay? So number two, if the distance between two objects is decreased by half, ladies, the force of attraction or repulsion increases 4 times. Okay? By half, that's 2. Square the 2, you get the 4. Okay? Simple math. Okay? See if you guys caught it next time you do the problem. Okay. Electric field. Around each object, there is an electric field that goes on. By definition, this is a region surrounding a charged object in which other objects are attracted or repelled by an electric force. Okay? Humanly speaking, that electric field could be anything. Okay? Attitude, could be behavior, words coming out of the mouth, something that's either going to attract or repel someone else. So on the negatives, you have, and the positives, you have this force that builds around each one of them. Okay? The strength of an electric field at a particular point is a vector. Oh, we bring this word back into the picture. Is a vector. Okay? Indicating how the field would affect a hypothetical positively charged object with no mass or volume, and we call that a test charge. Gabby, that's 2. Okay? So, the direction of the field in the direction of the test would move based upon the law of electric charges. Okay? And if we go back to electric charges, we got 2 of them. Well, we got the electric charge. It says the law stating that opposite charges attract each other and likes repel each other. Okay? So, number 1, away from positively charged objects, repel is happening. Repelling is happening. Toward the negative charged objects, attracting or the positive is happening. So the magnitude of the field is the force on the test charge. Okay? So, the electric field produced by a charged object is stronger closer to the object and stronger if the object has a greater charge. Okay? Simple enough, right? 2, Lena. We're moving up the scale, guys. So, this force around each object, each electron. Ricky, that's 1. if we put it into perspective like you see it on the screen now, with all these lines coming off of it, arrows and etc., we call these the lines of force. Okay? These are just arrows that include how a positive charge in the field would move. Okay? A positive test charge would follow a line of force in the direction of the arrow. A negative test charge would follow the line of force in the direction opposite of the arrow. Okay? So that's why you don't see a double arrow, because it's just a given. Okay? The one on the left, the picture on the left, does show you the arrows coming in from the positive into the negative. Okay? So when two electrical charges are brought close to each other, their electric fields interact through attraction or repulsion, changing those lines of forces. One exiting, one entering type thing. So when two electrical charges are brought close to each other, okay, so we got the attraction between unlike charges causes their lines of force to bend towards and connect with each other. The repulsion between the charges causes the lines of force from each charge to bend away from each other. Okay? The repulsion. So you have what's also called a uniform field in this. It's the electric field with an even strength throughout the process. These are the lines of force that are equally or evenly distributed between the two plates. Their direction is from the positive plate to the negative plate. Okay? So hopefully you got a little bit more understanding, even though this is basic information for you when it comes to electricity, static electricity, positives and negatives. Hopefully all this put it into perspective of what, what's really going on, how it's going on. Okay, again, 9.1, well, not again, but 9.1 is your homework tonight. Also reading pages 217 to 221, okay? So, as Isaac would say, DLs, may the force be with you. Have a good day.
All right, welcome to Algebra 1. We are on 5.2. 5.2, that is on page 159 of your textbook, page 159. One disadvantage of solving a system of equations with the graphing method is that the point of intersection must be estimated if the coordinates are not integers. We ran into this in 5.1. And they actually purposely put those problems in there to show you the disadvantage. Okay? The solution 4 and 1/7 and negative 2 and 1/3 would be very difficult to find using the graphing method because you try figuring out it's 1/7 and not 1/6. There's nothing on the screen yet. Chill. All right. To get an exact solution, use an analytical method like the substitution method rather than the graphing method. You're like, that's great, but how do we use the substitution method? Well, I'm about to teach you. All right. So, with the substitution method, one of the variables is eliminated by solving for a variable in one equation and substituting it into the other one. So I have here fine, I'll do it this way. I have here example A. Yes. You mean the pencils of shame? Okay. So let's look at how this works. Now, the first section I'm going to look at, everything is where you know is going to have an answer. Okay? Then I'm going to show you what happens when it doesn't have an answer. Okay? Because that will come up from time to time. So in this first system of equations, I have 5x plus y equals 3 and 2x minus 3y equals 12. So the first step is to get one variable by itself. Now, here's a trick. It's not required, but it's certainly helpful. Find the variable that's already by itself. So out of all those, which one is already by itself? Y in the first equation. No. The letter Y. Guys, I was saying the letter Y in the first equation, not asking a question. All right. So I'm going to take the first equation and solve for Y. Okay? Does that make sense? Okay. So first equation, top equation will always be in blue whenever I'm working on it. Bottom equation will always be in green whenever I'm working on it, just to help things stay consistent. Let's make sure we're not talking. Thank you. All right, so in this top equation, I'm just going to subtract 5x from both sides. Y equals negative 5x plus 13. The reason why I always grab the one where y is by itself, or whatever the letter is, by itself first, is because then I'm less likely to end up with fractions. Okay? And as much as we can work with fractions, let's face it, we don't enjoy it. Okay? So that's solved for y. That was actually pretty quick and easy. All right? Then, here's what we're going to do. In the bottom equation, okay, everyone watch the screen. Don't write anything down right now. Pencils down. Watch what I'm going to do because all of you are about to go, what? Okay? So just pay attention so I don't only have to explain it once. Okay? So I'm then going to rewrite the bottom equation. I'm going to keep x minus 3, and then I have y equals 12. Now, I just wrote that so I wouldn't have to change pens in the middle. Once I've solved for y, then I can plug that in. So now I have negative 5x plus 13. Yes, I just did. Yep. Now, that only works because we're looking for the single point that works for both equations. That's the only reason we can do this. Okay? Because we have a system of equations. You can't do that in generically. But if you're told it's a system of equations, then yes, you can do this. Okay? Which, anytime you're handed two equations, yes, it's a system. All right, does that make sense? Okay, let's not talk. Thank you. All right, so we took the second equation, plugged in the first equation. Now, notice, do you guys see something? What's missing? Y is missing. Oh, my word. Anyway, the letter Y is missing. Okay? So now I can solve. I can completely solve this set or this equation for x. It looks horrible. Okay? But we can solve this for x. Okay, so let's go through and rewrite it. I'm going to keep working in yellow. So 2x, amethyst. Please, but out. You're not in the class. Negative 3 times negative 5x, remember, is positive 15x. Negative 3 times positive 13 is negative 39. And this equals 12. See, it got a lot less messy real quick. Okay? Now we're going to combine like terms. 2x and 15x is? Thank you, person not in the class. Okay, well, let them. They're not as quick as you. That's not meant to be an insult. It's just reality. Like, that was great timing. Okay, give me a second because I need to fix something real quick because I haven't done it yet. Cool. All right, so first thing, what do I undo? I'm going to add 39 to both sides. What are you doing? No, sit down. Sit. Sit. That's why you're supposed to have two. Here. No. All right. Silence from over here, or I seriously will kick you out of the room. Okay? So we are adding 39 to both sides. In doing that, we get 17x is equal to what? 51. 51. Now, we divide both sides by 17. Fortunately, 51 is divisible by 17. So, x is simply equal to 3. Now, have I found a point yet? No. All I have found so far is I know that my... Oh, goodness, where did the dot go? All I know so far is that the x value is 3. So any guesses on how we find the y value? Not from you. Then go. What? Yeah, you plug it into the first equation. Out. I'm not asking. Oh, yes, you too. Both of you. I'm done. Okay, I'm trying to teach over here. Okay. So y is equal to negative 5 times the x we found in the second equation, which is 3, plus 13. And then we just work across. Negative 5 times 3 is? Negative 15 plus 13 is? Negative 2. Negative 2. Okay? So I have 3, negative 2. There's my answer. Huh? We came back up here and worked up here. I should probably not be right in the way of the answer. Cool. All right. So that's all you do. You then plug it back in, and then you're all set. All right. Do we understand the idea? Out.
That wasn't me. I'm serious. That was her. She literally was like, yes. Why do you have nothing to
Yes.
say? You actually said it.
Oh, yeah. All right. Part B. Or example B. Okay. Let's solve this one by substitution. Now, there's no possible way to avoid fractions in here. Okay. Everything has a coefficient. So, personally, I'm going to go with the one that's going to give me the least amount of fractions. So if you can't go for no coefficient, you want to go for one of the ones where the coefficients match. Okay? So I'm going to take the second equation and I'm going to solve for x. Now, why would I solve for x and not y? What makes it easier, though? The bottom equation solving for x is going to be my easiest solution. I just told you why it's going to be the easiest solution to use that equation, because the coefficients match, which is going to make a fraction disappear. Yay. Okay? Because it's going to end up being 5 over 5. So that's what I want to do, is I want to try to find something that's going to make my life easy. But then why would x be easier than y in this case? Yes? The numbers in front. Okay? Yes, because it's already positive. The y is a negative. If I have to suddenly introduce negatives all over the place, So, I mean, I can. It's just, why? Okay. So let's look at this bottom equation here. Okay? And we're going to solve down, we're going to add 5x to both sides. So we're going to add 5y to both sides. Equals 5y plus 4. Divide both sides by 5. X is equal to y plus 4/5. There's no avoiding that 4/5, but that's the least amount of damage we can get. Divided everything by 5. 4 divided by 5 is 4/5. Okay. By the way, make sure you stay in fractions if you're given fraction, or like work in fractions. It's a lot easier than the decimal. Okay. Yes. Divided by 5. Okay. So I'm going to... Dude, seriously, stop talking. Okay, I'm going to move this over here for the sake of space. All right, now in this top equation, that's where I'm going to have to plug in. So I've solved for x, so that's where I'm going to plug in. So I'm going to take this 3 times x, and I'm going to just leave myself parentheses for now, minus 2y equals 1. Okay? And then when we solved for x, we found out that x is equivalent to y plus 4/5. Okay, does that make sense? Okay. Now we can go through and just distribute. So we can distribute that 3 times y, which is 3y. 3 times 4/5. 3 times 4 is 12, so it's 12/5. Minus 2y equals 1. We can combine like terms. Okay, so 3y minus 2y is, or y. Plus 12 over 5 equals 1. Then we're going to subtract 12 over 5 equals 1, or we're going to subtract 12 over 5 from both sides, right? So minus 12/5, minus 12/5. Okay. Keep in mind 1 is 5/5. Okay, because 5 over 5. Yeah. So what is 5 minus 12? -7, and it's still over 5. Okay, does that make sense? Okay, so now I have a value for y. So again, as far as I've gotten, man, this thing likes to disappear, is I know I'm going to have something and -7 over 5 for the second part of my answer. Okay, or I could go through and make it a mixed number. When you're graphing, mixed numbers are more helpful. Okay, so if you have to graph, make it a mixed number, because then you can kind of guess where it is. Mixed number is when you have a whole number in front. So like this would be 1 2/5. Guys, this is elementary math, not even pre-algebra.
I'm not even looking.
Well, you did not go right on this number.
No, I know what a mixed number is below.
That. 5 goes into 7 once, there's 2 left over.
Oh, okay. That makes
Okay. Huh?
Oh, I was like,
The same way we've been doing it all year, man.
what the heck is this man doing? He's freaking dummy, magic.
Well, I mean, yes, but moving on. I mean, it's math. So same math, magic, same thing. All right.
It's called Bluetooth.
It's called USB. All right, anyway. Now, how do I find x then? Yep, plug it in. So guys, listen up. So x, let's try that again. Listen up. X is equal to y, which we have found by solving the top equation, is -7 over 5. And then I'm going to add in that 4 over 5 that we still had. Okay? So we have, then x is equal to -7 plus 4 is, yep, thank you, -3. So it's -3/5. So I have -3/5. What do you mean, how do we get negative? We added. What do you mean? Okay. There's the answer. Done. Obviously, you should be checking stuff. I'm not getting into that. All right. Yeah. What are you talking about? Step 6, this yields a solution of -3/5, -7/5. Okay. Okay. Example C. Okay, now I'm going to point something out here that would save us a lot of math and time if we notice it right away. Okay? Notice that these two equations are the exact same thing, except the second one is exactly double the first.
Oh yeah.
That means that the answer is the line.
The answer is the line.
The answer is the one line that gets drawn, because they're the same line. If everything, including signs though, that's the important bit. Everything has to match exactly, just different multiples. Infinite solutions, the line is the answer, and we would just write the first equation. Okay?
Write the line.
No. I'm going to forget. Okay. Anyway, so let's show you what happens if you don't see it though. So that way if you guys have this happen to you in the math, you know what's going on. Okay? But the short answer would just be write infinite solutions. And then the lines are, that's an E, coincident. I made it worse. Don't judge. All right. It's hard to write on this thing. All right. Infinite solutions, the lines are coincident, but what happens if we didn't see it? Well, then you solve one of them for one of the numbers. So let's solve the top. So I have 4x minus 2y is equal to 5. Let's solve it for y. So we get negative 2y equals negative 4x plus 5. Y equals then 2x plus, or sorry, no, minus 5 over 2. I am kind of burning through the solving of this because we already know the answer. Okay? So we get this, then we plug it into the other equation where we have 8x minus 4 times something equals 10. I'm going to plug in that something that we just found, which is 2x minus 5 over 2. All right. Then we start simplifying. We get 8x minus 4 times 2x is negative 8x. Negative 4 times negative 5 halves is positive 10. Do you see how it subtracts out to where we get 10 equals 10? If you get a no duh that's true statement, that means they're the same line. Are you sure? Should probably do the math then. So here's my point though. Okay, guys, listen. Eyes up here. Eyes. Yeah, thank you. That's what happens when the lines are the same. If you get a statement that's, well, yeah, of course 10 equals 10, it's itself. Notice then what would I plug back in? Okay, you're done at this point. You write infinite solutions, the lines are coincident. And yes, you need both parts. All right, one more example.
I finally got it. It took me a while to look back over it.
So our answer is the point, right?
Yes, the answer is the point, or in the case of example C here, if I can never find my cursor again, this is your answer. Okay, there's one more. Yes, what?
How does 8 minus 8 equal 10? I didn't see the plus 10.
Example D. Guys, example D, top one's going to be real fast to get to y because y is already by itself. It already has a fraction, but there's nothing I can do about that. So y equals negative 3 halves x plus 2. Okay? So in the bottom one, I'm going to say 3x plus 2 times negative 3 halves x plus 2. That's coming from over here. Rats. 2 times something equals negative 3. We get Austin. Adrian. Shh. We get negative 3 halves x plus 2 plugged in. And we go through and start solving. So we get 3x plus, and then we have to distribute this 2. So we get negative 3x plus 4. I know that we should have just written minus. I was already committed, and I don't feel like grabbing the eraser. Okay, 3x minus 3x cancels, so we got 4 equals negative 3. Well, does 4 equal negative 3? No. So when this happens, there is no solution. 2 times negative 3 over 2 is negative 3. The 2's cancel. Yeah. All right, no solution, we have parallel lines. And yes, you need both parts of that answer. Okay? Does that make sense? If you get to a contradiction where it's clearly no, that's not true, parallel lines, that means there is no solution because there's no point of intersection. There's no place on the graph where both lines work. Okay? Any questions? Cool, your homework is practice 5.2 blue due tomorrow. It's on the screen.